They're doing it right here in production. So ladies and gentlemen, please welcome Neelav Ghosh, Data Science Leader at Innovator.
Good afternoon, everyone, and thank you, Atsal, for the fantastic introduction and setting the stage for Innovator. Hi, everyone. I'm Neelav Ghosh. I lead the AI Center of Excellence at Innovator, where we are essentially building the platform for healthcare AI, the next generation healthcare intelligence platform for the decade. Before we get into the weeds of how we are using Agent primitives to build agents, it's important to understand who we are, which is the domain that we work for, how big is our footprint, and so on. At Innovators, our core mission is effectively to activate data for advancing health outcomes. How do we do that? It's via applications, analytics, generative AI agents, workflows, which are very, very healthcare focused. What started off as a decade back in primarily value-based healthcare is now expanded to the point where 90 million lives is what Innovator serves in the US. For perspective, that's 1 out of every 4 individuals, right? And as we do that, we serve personas across payers, providers, pharmacies, life sciences, name it, and we are there in the entire healthcare continuum. And 7 out of the 10 large healthcare systems are one of our customers in the US. How do we do this, right? So if you're building something of this scale and capability, foundation is absolutely super strong. And that's where Innovator Gravity comes into place. Right from data standardization, data quality, governance, security, guardrails, and also providing the runtime engines for hosting models. So that's where our platform plays a fundamental part. And once we have that, comes up a whole suite of vertically integrated products, be it in the space of RCM, value-based care, patient access, outreach, specialty care, actuarial analytics, and many more. How does Gravity help, and what would it be without Gravity? Prior to essentially Gravity, typically if you talk to a health system in the US, they would say anywhere between 10 to 12 or even more months to take the data, standardize. There's the whole question of data quality, building standard analytics, and then come value-driven healthcare workflows, right? So it's a whole slew which Gravity has fundamentally compressed. So you're getting a ready platform with these Lego blocks, arrange them, and then accelerate value to production. If we open up the hood of Gravity, there are a lot of technology components in there, right? Which is around security, the entire data platform layer. But the one box missing here is which takes us and is a great segue from what Vatsal talked about. Our Agent Dev Studio. Now, Agent Dev Studio, effectively built on top of Agent primitives, allows developers, AI engineers, app developers to accelerate any sort of agent building, specifically focused on healthcare workflows. At this point, they do not need to worry a lot about the security and governance of the data, where the data is hosted. All of that is largely taken care of by Gravity, and that's what Agent Dev Studio kind of gives you. If you have to map components of Agent Dev Studio and how primitives of Agent Core enable or accelerate any sort of building of agents, let's take fundamental components that we use from Agent Core and how they map, right? The first one, agent design and composition, right? If I have a team of 5 AI engineers, somebody would be using LangChain, one used OpenAI SDK, another is using small AI. At the end of it, it looks great in a notebook or a Visual Studio IDE, right? But then the question comes, what happens? How do you take it to runtime? Data scientists, the team that I lead, and a few AI engineers, they're not fundamentally strong at production grade builds, right? So somebody would do it just probably hosting the notebook. Somebody would do it using EC2 containers. Another one would say, okay, fine, let's do microcontainers, Docker. But at the end of it all, you need a unified standard platform or a runtime where your agents are running over a long period of time and at the same time very, very securely. And that's what runtime from Agent Core provides to us. Second is around enterprise and clinical context. Let me give you a user scenario, right? A patient walks into a physician's office and a conversation starts, an ambient AI agent starts listening to it, the physician starts to get next best actions or the decisions or the medications possibly to recommend, right? That is where you need consistently understanding the context of the conversation, maintaining short form memory, and answering or recommending any sort of information that the physician wants, right? Essentially reducing cognitive load. The patient steps away, returns after a couple of weeks for a next encounter. At that point, you need long form context to maintain or understand a patient's longitudinal history, which payer, what kind of insurance, and a lot of other kind of data points to ensure you are giving relevant information at that point in time. Agent core memory ensures you have long form as well as short form context maintenance for powering any sort of clinical agents, and that's where we store a lot of the enterprise clinical context codes and so on and so forth. The next one is around workflow orchestration and state. To probably create an analogy, in the typical SaaS world, or RPA agents, right? You exactly know what one step leads from one to the other to the next, right? It's very, very deterministic. In the agent world, you are living in a probabilistic world. You need dynamic discovery of agents, right? So you will have a whole slew of tools. Via a prompt, your agent needs to figure out which tool to pick up, which to call, and also, most importantly, maintain state across multiple calls in a multi-turn conversation, right? Sounds fancy.